Have you ever wondered what it feels like to ride a hurricane made of stars? When you look up at the Milky Way, you see a silent silvery river painted across the dark. The Romans called it Via Lactea. It feels peaceful. It feels still. If you could feel the reality. The Earth is hurtling through space at 828,000 kilometers per hour. We are not just watching the galaxy, we are surfing inside it. We are trapped in a spiral of 400 billion stars, spinning around a supermassive heart. Tonight, we embrace the motion. Welcome to the sleepy Cosmo. We have accepted the motion. We understand now that the ground beneath our feet is a raft, drifting on a current of gravity. But what does the river itself look like? From our vantage point on Earth, buried deep inside the disk, we have a terrible view. We are like a microscopic insect living inside a glass pane. We can look left and right and see the glass stretching out to the horizon, but we cannot step back to appreciate the shape of the window. To truly understand the Milky Way, we must perform an act of imagination. We must detach our consciousness from the Earth, rise up through the atmosphere, past the moon, past the planets, and fly perpendicular to the galactic plane. We must travel upwards for thousands of light years until we can look down upon our home. From this God's eye view, the river disappears, and the Leviathan reveals its true form. It is not a shapeless cloud. It is a masterpiece of spiral architecture, glowing against the absolute black of the intergalactic void. The first thing you notice is that the classic image of a pinwheel is slightly wrong. For decades, astronomers thought the Milky Way was a simple spiral galaxy, a round, glowing yolk in the center with arms curving out gently. But modern observations, peering through the dust with infrared eyes, have revealed a more complex and muscular structure. We live in a barred spiral galaxy. The heart of our galaxy is not spherical. It is a rectangular bar of old yellow stars, stretching across the center for thousands of light years. It looks like a glowing baton spinning in the dark. This bar is a cosmic funnel. It acts as a mechanism to channel gas from the spiral arms inward, feeding the hungry core. Attached to the ends of this rotating bar are the great spiral arms, the Scutum Centaurus and Perseus arms, sweeping out into the dark like ribbons of blue fire. These arms are density waves, traffic jams of gravity where gas is compressed and new stars are born, lighting up the structure like neon signs on a rainy street. As we stare at this structure, we must confront the sheer scale of it. The disk of the Milky Way is approximately 100,000 light years across. To walk from one edge to the other at the speed of light would take 100 millennia. Yet, despite this immense width, the galaxy is shockingly thin. The main disk, where the majority of stars live, is only about 1,000 to 2,000 light years thick. If you were to shrink the Milky Way down to the size of a vinyl record or a dinner plate, it would be just as thin, perhaps even thinner. It is a fragile sheet of light spinning in the void. And like an old vinyl record left out in the sun, it is not perfectly flat. Recent data shows that the Milky Way is warped. The edges of the disk are bent, twisting upward on one side and downward on the other, likely the result of a gravitational tug-of-war with our satellite galaxies, the Magellanic Clouds. It is a beautiful imperfection, a sign that our home is flexible, reacting to the invisible currents of gravity surrounding it. Now, let us find ourselves on this map. Where is the Earth? We do not live in the busy downtown core, the bulge, where stars are packed so tightly that the night sky would be white with radiation. Nor do we live in the desolate, frayed edges of the rim. We inhabit the Goldilocks zone of the galaxy, the galactic suburbs. Specifically, we are located about 26,000 light years from the center. We reside in a minor structure known as the Orion Cygnus Arm, or simply the Orion Spur. It is a bridge of stars connecting the two major arms, Sagittarius and Perseus. It is a quiet, stable neighborhood. The density of stars here is just right, close enough to have enriched our solar system with heavy metals necessary for life, but far enough apart that we are not constantly bombarded by exploding supernovae or perturbed by passing stars. From this safe harbor, we watch the rest of the galaxy rotate past us, a slow parade of 400 billion suns. The number is difficult to hold in the mind. 400 billion stars. Imagine a beach. Pick up a handful of sand. There are perhaps 10,000 grains in your hand. Now, imagine the entire beach. That is the Milky Way. Each grain is a sun, Some are red dwarfs, cool and dim, burning for trillions of years. Some are blue giants, living fast and dying young in violent explosions. And orbiting these stars are the planets. For a long time, we wondered if our solar system was unique, but the Kepler mission and subsequent studies have taught us a staggering truth. Planets are as common as stones. On average, every star you see has at least one planet. Many have systems of 5, 7, or more. This means there are likely trillions of planets in our galaxy alone. The Milky Way is not just a collection of nuclear furnaces, it is a collection of worlds. It is an archipelago of potential surfaces, potential oceans, and potential homes. But there is a final, haunting layer to this anatomy. The galaxy is not just made of stars and the planets that orbit them. In the deep, pitch-black spaces between the stars, there exists a hidden population. These are the rogue planets, or free-floating planets. These are worlds that were born around stars, but were violently ejected, kicked out of their solar systems by the gravitational tantrums of shifting gas giants. Now, they drift through the interstellar night, untethered to any sun. They have no day. They have no year. They wander the galaxy in eternal darkness. Recent estimates suggest that these orphans might outnumber the stars themselves. There could be billions of them, Earth-sized rocks, Jupiter-sized giants, floating silently past us in the void. They are the ghosts of the Milky Way, invisible to our eyes, detected only when their gravity briefly bends the light of a distant star. They remind us that the galaxy is wilder and lonelier than we dare to admit. As we drift back down from our God's eye view, descending through the thin, warped disk, past the glowing bar, and settling back into the quiet spiral of the Orion Spur, we realize that the anatomy of a Leviathan is not a static skeleton. It is a living body. It has a heart that beats. It has arms that embrace the dark. It has a breath that circulates elements. And like any living thing, it has a history. It was not born this size. It did not simply appear as a grand spiral 13.6 billion years ago. It grew, it fought, it ate. The stillness of the stars around us masks a violent past. To understand how the Milky Way became this majestic city of stars, we must look at the scars it hides in its halo. We must learn the history of the cannibal. We have gazed down upon the spiral majesty of the Milky Way from above, admiring its glowing arms and its sleek barred core. We have mapped the quiet suburbs of the Orion Spur where our sun resides. To the casual observer, and indeed to astronomers for most of human history, our galaxy appeared to be a singular, majestic entity, a monolith of light that formed in isolation and spun peacefully in the dark for eons. We imagined it growing like a tree, slowly and steadily from a single seed of primordial gas. But this image of serene, solitary growth is a fabrication. The truth is far bloodier, far more chaotic, and infinitely more fascinating. As we peel back the layers of light and look at the motion of the stars with the precision of modern instruments, the Milky Way reveals its true nature. It is not a tree, it is a predator. It is a scavenger. It is a galactic cannibal that has grown to its immense size not by creating new stars from scratch, but by hunting, capturing, and devouring its smaller neighbors. The beautiful spiral we call home is, in reality, a graveyard of eaten galaxies. It is a patchwork quilt stitched together from the corpses of the conquered. Tonight, we are going to act as cosmic archaeologists. We are going to dig into the fossil record of the heavens to reconstruct the violent history of how we came to be. To understand the scale of this history, we must first confront the age of the foundation itself. The Milky Way is old, incredibly old. The universe itself is estimated to be 13.8 billion years old. The oldest stars in the Milky Way have been dated to approximately 13.6 billion years. This means our galaxy is not a late arrival. It is one of the original inhabitants of the cosmos. It began forming in the Dark Ages, shortly after the first light of creation flickered on. In those early days, the universe was small, dense, and crowded. It was a mosh pit of protogalaxies, messy, irregular blobs of gas and dark matter swarming around each other. There was no order. There were no grand spirals. There was only gravity and collision. Our galaxy began as a dominant clump of dark matter, a gravity well that started pulling in everything around it. It didn't ask permission. It simply swallowed the gas clouds and small star clusters in its vicinity. growing fatter and heavier with every meal. This process is called hierarchical assembly, a polite scientific term for a game of big fish eats little fish. But how do we know this? How can we reconstruct a crime that happened 10 billion years ago? The evidence lies in the movement. In a settled galaxy, stars born together tend to move together. The stars in the thin disk of the Milky Way, like our sun, all rotate in a fairly orderly fashion, bobbing up and down slightly like horses on a carousel. But when astronomers began using the Gaia Space Telescope, launched by ESA, to map the precise 3D positions and velocities of over 1 billion stars, they found something strange. They found immigrants. They found populations of stars that were moving wrong. These stars weren't following the traffic flow of the disk. They were moving on highly eccentric, elongated orbits. Some were even moving backward, retrograde, against the rotation of the rest of the galaxy. Even more telling, the chemical composition of these stars was different. They had lower levels of heavy metals, metallicity, than the native stars of the Milky Way. In astronomy, low metallicity is a fingerprint of origin. It suggests a star was born in a smaller, more primitive galaxy that didn't have the engine power to forge heavy elements. These wrong-way stars are the smoking gun. They are the undigested bones of the galaxies we ate. The most significant of these meals, the main course of our galaxy's history, happened about 10 billion years ago. This was an event that fundamentally reshaped the Milky Way, transforming it from a modest proto-galaxy into the giant we see today. Astronomers call this victim Gaia Enceladus, or more colorfully, the Gaia sausage, named for the sausage-like shape of the velocity graph produced by its debris. Gaia Enceladus was not a small snack. It was a substantial dwarf galaxy, perhaps a quarter of the size of the Milky Way at the time. Imagine the collision. It wasn't a gentle merger, it was a head-on crash. Gaia Enceladus slammed into the young Milky Way with tremendous energy. The collision didn't destroy the stars. Stars are too small to hit each other, but it shattered the structure of both galaxies. The gravity of the Milky Way ripped Gaia Enceladus apart, stripping away its gas and scattering its stars. But the Milky Way did not escape unscathed. The energy of the impact was so great that it puffed up the disk of our galaxy. Before the crash, the Milky Way was likely a thin, delicate disk. The impact heated the stars, kicking them into higher, more chaotic orbits. This created what we now call the thick disk and the stellar halo. The halo is a vast spherical cloud of old stars that surrounds the main spiral disk like a swarm of bees. If you look at the halo today, a huge percentage of the stars there are not native to the Milky Way. They are the refugees from Gaia Enceladus, trapped forever in the gravity of the conqueror. This collision was the defining moment of our youth. It reset the clock. It triggered a massive burst of star formation as the gas clouds of the two galaxies collided and collapsed. It is very possible that the shock waves from this violent era set the stage for the later formation of the region where our sun would be born. We are the children of that violence. But the feasting did not stop 10 billion years ago. The Milky Way is a creature of perpetual hunger. Even as we speak, right now, at this very second, the digestion continues. If you could see gravity with your eyes, you would see that our galaxy is wrapped in ribbons of light called stellar streams. These are long, thin filaments of stars that wind around the Milky Way, like spaghetti wrapped around a fork. These streams are the ghosts of dwarf galaxies and globular clusters that strayed too close. The physics of this destruction is governed by tidal forces. When a small satellite galaxy approaches a massive giant like the Milky Way, the side of the satellite facing us feels a stronger pull than the side facing away. This difference in gravity stretches the satellite. It pulls it apart, layer by layer. The stars spill out, first from the front, then from the back, forming a leading tail and a trailing tail. Over hundreds of millions of years, the satellite dissolves completely, leaving only a stream of stars tracing its final orbit. The most famous of these current victims is the Sagittarius dwarf spheroidal galaxy. This is a small galaxy that was discovered only recently, in 1994, because it is hiding on the other side of the galactic core, obscured by dust. The Sagittarius dwarf is currently crashing through the disk of the Milky Way. It has actually punched through our disk 3 times in the last few billion years. Each time it passes through, it gets stripped of more stars. It is currently in its death throes. Its stars are being siphoned off into a massive stellar stream that wraps over and under our galaxy, a cosmic ribbon that contains hundreds of millions of suns. The Sagittarius stream is so immense that it covers a huge portion of the sky, invisible to the naked eye but glaringly obvious to our data maps. This little galaxy is putting up a fight, but it is a losing battle. Eventually, perhaps in another billion years, the core of the Sagittarius dwarf will dissolve completely, and its identity will be erased. Its stars will simply become Milky Way stars, their history forgotten by all but the most diligent astronomers. And it is not just the Sagittarius dwarf. The Magellanic Clouds, our two famous neighbors visible in the southern sky, are also being drained. A vast bridge of gas called the Magellanic Stream connects them to the Milky Way. We are sipping their fuel like a milkshake through a straw. We are stealing the hydrogen gas they need to make new stars. This gas falls onto the Milky Way, replenishing our own supply and fueling the birth of new suns in our spiral arms. This is a crucial realization. Cannibalism is not just about growth, it is about survival. A galaxy that stops getting fresh gas will eventually die out. By stealing gas from its neighbors, the Milky Way keeps itself young. It stays blue and vibrant. It is a vampire, sucking the lifeblood of smaller systems to maintain its own immortality. There are also smaller skeletons in the closet. Look at the globular clusters, those beautiful dense balls of ancient stars that orbit in the halo. We used to think they were just simple clusters formed within the Milky Way. But recent forensic evidence suggests that some of them, like the massive Omega Centauri, are actually the stripped cores of captured dwarf galaxies. Omega Centauri is millions of times the mass of the Sun and has a complex population of stars that doesn't fit the profile of a normal cluster. It is likely the nucleus of a galaxy that was eaten long ago. The Milky Way stripped away all its outer stars, leaving only the dense, indigestible nut of the core. It now orbits us as a trophy, a prisoner of war on eternal parade. This view of the galactic cannibal changes how we perceive our place in the universe. We often think of alien worlds as things far away, but the truth is, there are alien worlds passing through our backyard right now. There are stars in our night sky that were born in a completely different galaxy, light years away from the Milky Way, only to be kidnapped and brought here. There are planets orbiting those stars that witnessed the collision. Imagine living on a planet in the Gaia Enceladus galaxy 10 billion years ago. You would have seen the Milky Way not as a band of light, but as a terrifying spiraling monster growing larger in the sky every night until it filled the horizon and the sky tore apart. Civilization on such a world would have survived the merger physically. Solar systems rarely collide, but their sky would have been remade. They would have gone from living in a small, cozy galaxy to being lost in a giant metropolis. As we look at the Milky Way now, we must see it as a mosaic. It is a tapestry woven from the threads of destruction. Every stream, every halo star, every wrong-way mover is a testament to the immense gravity that binds us. We are safe because we are the big fish. We are the heavy gravity well. But this dominance comes with a cost. The galaxy is a chaotic, messy, evolving thing. It is not a static sculpture. It is a flowing river of time and matter, constantly merging, constantly reshaping. The quiet silver river we see from Earth is actually a roaring torrent of assimilation, and the most humbling thought of all is that this process is not over. We are still eating. The Sagittarius dwarf is dying right now. The Magellanic Clouds are being drained, and in the distance, a much larger rival is watching. We have spent billions of years being the predator, eating the small fry. But in the deep future, we are destined to meet our match. We will face an opponent that we cannot eat. We will face a collision that will not result in a simple assimilation, but in a total transformation of our identity. But before we look to that distant future, we must look inward. We have talked about the body of the galaxy, its limbs, its scars, and its meals. But what controls it? What lies at the absolute center of this swirling mess? What is the anchor that holds 1.5 trillion solar masses of material in place? We must travel 26,000 light-years from our home, through the dust lanes of the Sagittarius Arm, through the dense radioactive crowds of the galactic bulge, to find the dark heart of the city. We are going to meet the king. We are going to meet the reason the galaxy spins. Prepare to enter the zone of extreme gravity. We are approaching Sagittarius A skis. We have explored the spiraling arms of the Milky Way, tracing the wreckage of the galaxies it has consumed. We have mapped the quiet, safe neighborhood of the Orion Spur where our sun drifts. But a galaxy is not just a collection of arms. It is a wheel, and every wheel needs an axle. To find the engine that drives this massive city of 400 billion stars, we must leave the safety of the suburbs and travel inward. We must journey 26,000 light years toward the center. As we fly deeper into the galaxy, the scenery changes. In our night sky on Earth, we see perhaps a few thousand stars with the naked eye. But as we approach the galactic bulge, the sky becomes crowded. The darkness between the stars begins to disappear. If you lived on a planet inside the bulge, you would not have a night. The sky would be ablaze with the light of millions of old red giants packed together like people in a crowded square. The radiation here is intense. The stellar winds are violent. This is the downtown of the Milky Way, a chaotic, high-energy metropolis where stars live only light weeks apart, constantly jostling for space. And sitting at the absolute center of this chaos, hidden behind thick curtains of interstellar dust that block visible light, lies a region that for decades was a mystery. Astronomers called it Sagittarius A, pronounced Sagittarius A star. For a long time, we knew something was there because we could hear it screaming in radio waves. But we couldn't see it. It was a ghost in the machine. It was only by watching the behavior of the subjects that we finally identified the king. In the 1990s, astronomers began tracking a group of daring stars known as the S stars, S2, S62, and others, located deep in the core. These stars were not drifting leisurely like our sun. They were sprinting. They were whipping around an invisible point in space at speeds of millions of kilometers per hour. One star, S2, was observed completing a sharp, hairpin turn around nothing. It swung around the empty point like a comet swinging around the sun, accelerating to 25 million kilometers per hour, nearly 3% of the speed of light, before shooting back out. The physics was undeniable. The only thing small enough to fit inside that hairpin turn, yet heavy enough to whip a star at that speed, had to be an object of infinite density. We had found it. We had calculated the weight of the ghost. Resting in the exact gravitational center of the Milky Way is a supermassive black hole weighing 4.1 million times the mass of the Sun. Let us try to visualize Sagittarius A. When we hear 4 million suns, we imagine something physically enormous, perhaps a ball of darkness swallowing the sky. But the terrifying truth about black holes is their compactness. Mass creates gravity, but density creates the abyss. The event horizon of Sagittarius A, the point of no return, is shockingly small. It has a diameter of roughly 25 million kilometers. To put that in perspective, the orbit of Mercury around our sun is about 58 million kilometers wide. This means the monster that anchors our entire galaxy would fit comfortably inside the orbit of Mercury. If you replaced our sun with Sagittarius AR, the black hole wouldn't even touch the Earth. It is a tiny, dense pinprick in the fabric of space-time, and yet, this pinprick wields enough power to force 400 billion stars to march in circles for billions of years. It is the ultimate example of the invisible anchor. It is small, silent, and absolute. For decades, this was all we knew, math and indirect observations. But on May 12, 2022, the world changed. The Event Horizon Telescope, EHT, a global network of radio dishes linked together to form an Earth-sized eye, released the first direct image of our own black hole. It wasn't a sharp photograph like a portrait. It was a blurry, glowing orange donut set against the black. But that blur was history. We were looking at the shadow of the black hole. We were seeing the glow of superheated plasma, gas from crushed stars and dust, swirling around the event horizon at relativistic speeds. The dark patch in the center was the silhouette of the monster itself, the region where light had been captured and deleted from the universe. That image proved that the dark heart is real. It is not a mathematical fiction. It is a physical object, burning with the heat of friction, sitting there in the dark, watching us. However, compared to the other monsters we have met on this journey, like TON 618 or the quasars of the early universe, Sagittarius A is remarkably quiet. It is what astronomers call a quiescent, or starving black hole. It is not currently feasting on a large meal. It is on a diet. The accretion disk is faint. The jets are weak or non-existent. It flickers occasionally, swallowing a small asteroid or a puff of gas, like the famous object G2 that grazed it in 2014, letting out a brief flare of X-rays, but mostly, it sleeps. This dormancy is the reason we are alive. If Sagittarius A Chiron were an active galactic nucleus, if it were feeding aggressively like a quasar, it would be blasting lethal jets of radiation into the galaxy. It could sterilize the inner thousands of light years, stripping the atmospheres off planets and preventing life from evolving. Its silence is our safety. It rules the galaxy with a gentle hand, holding us in orbit without burning us to ash. There is a profound psychological comfort in knowing it is there. A spiral galaxy without a black hole is unstable. It is a disk without a spindle. Sagittarius A Chiron provides the center. Every time you look at the Milky Way stretching across the sky, you are looking toward it. The stars you see are moving because it is pulling them. Our sun, located 26,000 light years away, feels the tug. We are in a stable, circular orbit around this dark heart. We take 250 million years to complete one lap, a galactic year. The last time we were in this position, relative to the black hole, the first dinosaurs were walking on Pangaea. The next time we complete a lap, humanity will likely be long gone or evolved into something unrecognizable. The black hole is the clock by which we measure deep time. It is the permanent fixture in a transient universe. But while the black hole is the anchor, it is not the only mystery in the galaxy. We have looked at the stars, and we have looked at the monster that herds them. But what about the worlds that have no sun? What about the objects that slip through the cracks? As we drift away from the intense gravity of the center, back toward the cooler, darker expanses of the spiral arms, we must turn our sensors to the invisible population that outnumbers the stars themselves. We are going to look for the orphans. We are going to look for the rogue planets, the worlds that wander in the eternal night, untethered to any anchor, drifting silently between the fires. Prepare to leave the heat of the bulge. We are heading into the deep cold. We are hovering in the chaos of the galactic center. Beneath us lies the swirling accretion disk of Sagittarius A Sco, the 4 million solar mass anchor of our world. To our eyes and to our optical telescopes, the beast appears calm. It is on a starvation diet, flickering only faintly. We feel safe. We assume that the violent days of the Milky Way are ancient history, lost billions of years in the past. But if we switch our vision, if we take off our human glasses and put on the gamma-ray goggles of NASA's Fermi telescope, the sky suddenly changes. The darkness above and below the galactic disk disappears. In its place, we see two colossal glowing monuments of energy that shock the mind. We see that the galaxy is not sleeping. It is breathing fire. These are the Fermi bubbles. Discovered only recently in 2010, they are one of the largest structures in our entire galaxy. Yet they remained hidden from humanity for all of history until we built eyes capable of seeing high-energy radiation. Imagine the Milky Way as a flat dinner plate. Now, imagine two giant balloon-like lobes of superheated gas and magnetic fields expanding outward from the center, one rising high above the top of the plate and the other extending deep below the bottom. These are not small puffs of smoke. Each bubble stands 25,000 light-years tall. Together, they span a distance of 50,000 light-years, half the diameter of the entire galaxy itself. They are towers of invisible light, towering over the spiral arms, filled with cosmic rays moving at near light speed. What created these titans? The forensic evidence points directly back to the sleeping monster we just visited. The bubbles are the result of a cataclysmic explosion, a massive burp from Sagittarius A Maya. Astronomers estimate that this event happened relatively recently, perhaps 3 to 6 million years ago. To put that in perspective, 6 million years ago, the ancestors of humanity, early hominids, were already walking upright on the plains of Africa. When our ancestors looked up at the night sky, they saw the same stars we see today. They had no idea that Deep in the core of the galaxy, the black hole had just swallowed a massive meal, perhaps a giant cloud of gas or a stray star cluster. The black hole couldn't digest it all. It choked. It blasted the excess energy out in two focused jets of fury, punching through the halo of the galaxy and inflating these bubbles with the power of millions of supernovae exploding at once. This realization is chilling. It means the peaceful suburbs theory is fragile. We missed a galactic eruption by a cosmic blink of an eye. If the solar system had been located closer to the center, say within a few thousand light years, that eruption might have stripped our ozone layer and sterilized our planet. But out here, 26,000 light years away, we were safe. The bubbles expanded vertically, perpendicular to the disk, sparing the life-bearing worlds in the spiral arms. We were protected by the geometry of the explosion. The galaxy literally vented its rage into the empty void above and below, rather than blasting its own children. The existence of the Fermi bubbles fundamentally changes our mental image of the Milky Way. We are taught to think of galaxies as 2D objects, flat disks spinning in space. But the bubbles show us that the Milky Way is a 3D object. It has a vertical anatomy. It has a halo that is active and alive. The bubbles are still expanding today, moving at millions of kilometers per hour, carrying with them heavy elements, metals, forged in the core, and spraying them out into the deep intergalactic medium. This is the galactic wind. It is a recycling system. The black hole shoots material out. Eventually, that material cools, rains back down onto the disk like a cosmic fountain, and becomes the fuel for new generations of stars. As we stare at these towering violet ghosts in our mind's eye, we realize that the galaxy is more like a living organism than a machine. It eats, it digests, it belches energy, it circulates nutrients. The Fermi bubbles are the visible breath of the dragon. They remind us that the stillness of the night sky is just a pause between breaths. The monster is not dead. It is merely waiting for the next meal to wake it up again. But now, we must look beyond the gas and the fire. We have seen the stars, the black hole, and the energy bubbles. But if you were to put all of these things on a cosmic scale, every star, every cloud, every bubble, they would only account for about 15% of the galaxy's mass. The math doesn't add up. The galaxy is spinning too fast. By all laws of physics, the stars at the edge, like our sun, should have been flung off into deep space billions of years ago, like water spinning off a bicycle wheel. Something else is holding us in. Something invisible, something heavy. We are about to leave the realm of the visible entirely. We are going to hunt for the ghost skeleton of the Milky Way. We are going to explore the mystery of dark matter. We have spent the last hour marveling at the visible wonders of our galaxy. We have been dazzled by the light of 400 billion stars. We have stared into the glowing orange eye of Sagittarius Aetiung. We have watched the violet fire of the Fermi bubbles towering over the galactic disk. These sights are magnificent. They are titanic. But I must tell you a difficult truth. Everything we have seen so far, every star, every cloud of nebula, every black hole, every atom in your body, every photon of light, is merely the decoration. It is the paint on the walls, but it is not the house. If you were to put the Milky Way on a cosmic scale and weigh it, all the glowing stuff we can see would account for only about 15% of the total mass. The vast majority of our galaxy, the remaining 85%, is completely invisible. It is missing. We are living in a galaxy made of ghosts. Tonight, we must turn our attention away from the light and stare into the empty spaces, because that is where the true body of the Leviathan hides. We are entering the realm of dark matter. To understand why we believe in this invisible monster, we must go back to the basic laws of motion that govern the universe. Imagine a merry-go-round spinning on a playground. If you put a heavy ball near the center, it spins slowly and stays put. But if you put that ball on the very edge and spin the wheel as fast as you can, the ball will fly off. This is centrifugal force. Gravity acts as the rope holding the ball in. For the ball to stay on, the edge, the gravity pulling it in, must be strong enough to counteract the speed pushing it out. In the solar system, this follows a predictable pattern. Mercury, close to the sun, moves very fast, 47 km/h, to avoid falling in, while Neptune, far from the sun, moves very slowly, 5 km/h, because the sun's gravity is weaker out there. If Neptune moved as fast as Mercury, it would be flung out of the solar system instantly. In the 1970s, the astronomer Vera Rubin pointed her spectrograph at the edges of spiral galaxies, including our neighbor Andromeda and our own Milky Way. She expected to see the same pattern: stars near the dense core moving fast, and stars at the lonely, sparse edges moving slow. But she saw something impossible: the stars at the edge, stars like our sun, and those even further out, were moving just as fast as the stars in the center. In the Milky Way, our sun is racing at 230 kilometers per second. Stars 50,000 light years out are also racing at nearly 230 kilometers per second. By all the laws of Newtonian physics and Einstein's general relativity, the galaxy should not exist. With that rotational speed, and with the meager amount of gravity provided by the visible stars, the Milky Way should have torn itself apart billions of years ago. The stars at the edge should have been flung into the intergalactic void like water droplets shaking off a wet dog. But they didn't fly off. They are still here. They are being held in a grip of iron. This observation led to an inescapable conclusion. There must be more gravity than we can see. There must be a source of mass that does not shine, does not reflect light, and does not block light. It is completely transparent, yet it is heavy. Astronomers calculated that to hold the Milky Way together at these speeds, this invisible matter must outweigh the visible matter by a factor of nearly 6 to 1. We are not living in a disk of stars. We are living in a gigantic sphere of dark matter. Imagine a beach ball. Now imagine a small, flat coin floating in the exact center of that beach ball. The coin is the glowing Milky Way, the stars, the gas, the spiral arms. The beach ball is the dark matter halo. We are surrounded on all sides, above and below, by this vast, invisible cocoon. It extends out to 300,000 light years from the center, far beyond the furthest stars. This changes our perception of reality. We tend to think of the stars as the main characters of the universe because they are bright and we can see them. But in the grand scheme of things, the stars are just the glitter sprinkled on top of the dark matter structure. Dark matter is the scaffolding. It is the skeleton. In the early universe, dark matter clumped together first, creating the gravitational wells that pulled in the normal gas to form stars. Without dark matter, there would be no Milky Way. The gas would never have concentrated enough to form galaxies. We would not be here. We are the bioluminescent moss, growing on a mountain of rock that we cannot see. But what is it? This is the question that haunts modern physics. For decades, scientists wondered if dark matter was just ordinary stuff that happened to be dark. Broken planets, dead stars, black holes, objects called MACOs, massive compact halo objects. But we have searched for these. We have stared at the background stars to see if they twinkle as these dark objects pass in front of them, micro-lensing. We found very few. There are not enough dead stars to account for the missing mass. The conclusion is even stranger. Dark matter is not made of atoms. It is not made of protons, neutrons, or electrons. It is something else entirely. It is non-baryonic matter. It is a ghost particle, likely a WIMP, weakly interacting massive particle, that has mass but refuses to interact with electromagnetism. This means that dark matter is not just out there in space. It is here. It is in this room. Because the Milky Way is rotating through this static halo of dark matter, we are constantly moving through a dark matter wind. Right now, billions of dark matter particles are passing through your body every second. They are passing through the roof of your house, through your skin, through the earth itself, and coming out the other side without touching a single atom. To a dark matter particle, the earth is as insubstantial as a ghost. They flow through us like wind through a wire fence. We are completely permeable to them. We are swimming in an ocean of invisible weight, completely unaware of the tide. Scientists have built cathedrals to catch these ghosts. Deep underground, in abandoned gold mines and beneath mountains, shielded from cosmic rays by kilometers of rock, there are vats of liquid xenon and germanium crystals, like the Xenon 1T or LUX experiments. These detectors are waiting for the rarest of events. The moment when a single dark matter particle accidentally crashes into a nucleus of normal matter, creating a tiny flash of light or a microscopic vibration. These scientists sit in the dark, watching the screens. listening to the silence, waiting for the universe to whisper its secret. So far, the detectors have remained mostly quiet. The ghost remains elusive, but the gravity is real. The speed of the stars is real. The scaffold is there. The existence of the dark matter halo also explains the fate of our neighbors. Remember the Magellanic Clouds, those satellite galaxies we discussed? They are orbiting within the Milky Way's dark halo. They are moving through the invisible fluid. As they plow through the dark matter, they experience dynamical friction, a gravitational drag that slows them down. It is like trying to run through water. This friction is causing their orbits to decay. Slowly, inexorably, the dark halo is dragging them inward. It is the spider web that has caught the flies. Without the dark matter halo to slow them down, the Magellanic Clouds might have zipped past us and escaped into the void. But the halo caught them. It sealed their fate. There is a profound humility in accepting the reality of dark matter. For centuries, humans believed the Earth was the center of the universe. Copernicus moved us to the side, orbiting the sun. Hubble moved us further, to a random galaxy among billions. Now, dark matter has delivered the final insult. Not only are we not the center, but we are not even made of the primary stuff of the universe. We are the minority. The normal matter, the stuff of rocks, water, stars, and people, is a rare, exotic foam floating on the deep ocean of the dark. We are the exception. The universe belongs to the invisible. As we drift through this invisible scaffold, feeling the phantom wind pass through our ship, we must remember that this structure does more than just hold the galaxy together. It also seals us in. The immense gravity of the halo creates a deep potential well. To escape the Milky Way entirely, you would need to achieve a velocity of over 550 kilometers per second. It is a velvet cage. It holds the gas needed for future star formation, preventing it from evaporating into intergalactic space. It ensures that the Milky Way remains a fertile, living system for billions of years to come. But even this mighty skeleton is not invincible. The dark matter halo protects us from internal disintegration, but it cannot protect us from an external equal. We are not the only giant in the neighborhood. Across the void, another massive halo is approaching. Another invisible sphere, carrying its own cargo of 1 trillion stars, is rushing toward us. The skeleton of the Milky Way is about to lock horns with the skeleton of Andromeda. We have seen the past, the cannibal. We have seen the center, the black hole. We have seen the frame, dark matter. Now we must turn our eyes to the future. We must look at the clock. The countdown has already begun. The sky is going to change. We have explored the body of the Milky Way, from its violent core to its invisible dark matter skeleton. We have established that our galaxy is a behemoth, a gravitational tyrant that rules its corner of the universe with an iron fist. But a tyrant does not rule in a vacuum. A king needs subjects. As we drift outward, leaving the dense spiral arms and floating into the vast, lonely halo that surrounds our galaxy, we realize that the Milky Way is not alone. It is the head of a dysfunctional family known as the local group. This is a cluster of more than 50 galaxies bound together by gravity, dancing a slow, complex dance in the void. Most of these are tiny dwarf galaxies, faint, shapeless collections of stars that swarm around the Milky Way like moths around a street lamp. They are the leftovers of creation, the crumbs that didn't make it into the main cake. But among this swarm, there are two distinct bright companions that have captivated human imagination for millennia. They are not just specks of light. They are full-fledged galaxies in their own right, and they are currently locked in a death spiral with us. They are the large and small Magellanic Clouds. To see them, you must travel to the southern hemisphere. If you stand in the deserts of Chile, the bush of Australia, or the plains of South Africa on a moonless night, you will see two luminous, misty patches detached from the Milky Way. They look like pieces of the galaxy that have broken off and drifted away. For thousands of years, the indigenous peoples of the South wove them into their dreamtime stories. To the Polynesians, they were clouds of navigation. To the Persians, they were the white ox. But to the Western world, they were named after Ferdinand Magellan, whose crew observed them during their circumnavigation of the globe in the 1500s. They described them as clouds of mist that never moved, even when the wind blew. It wasn't until the 20th century that we realized these clouds were actually separate cities of stars, the Large Magellanic Cloud LMC, and the Small Magellanic Cloud, SMC, orbiting our own galaxy at a distance of about 160,000 and 200,000 light-years, respectively. They are close. In cosmic terms, they are practically in our living room, and because they are so close, we can see the damage we are doing to them. These are not elegant spirals like the Milky Way. They are irregular galaxies. They look chaotic, twisted, and torn. This deformation is not an accident, it is a crime scene. For billions of years, the immense gravity of the Milky Way has been pulling at them, stretching them, and distorting their shapes. They are being bullied, but the interaction is not just gravitational, it is atmospheric. As these two galaxies orbit us, they are plowing through the Milky Way's diffuse halo of hot gas. This creates a phenomenon known as ram pressure stripping. Imagine driving a convertible with the top down at high speed. The wind rips the hat off your head. The wind of the Milky Way's halo is ripping the gas out of the Magellanic Clouds. They are bleeding hydrogen as they fly. This leads to one of the most spectacular unseen features of our sky, the Magellanic Stream. If our eyes could see radio waves, specifically the 21-centimeter emission of neutral hydrogen, the night sky would look terrifying. We would see a massive ribbon of gas, a river of blood, trailing behind the Magellanic Clouds. This stream wraps more than 100 degrees across the sky. It is a bridge of stolen material connecting the satellites to the master. This gas is being siphoned off the clouds and falling onto the Milky Way. It is a slow-motion transfusion. The Milky Way is drinking their blood to keep itself young. As this fresh, metal-poor gas falls into our disk, it fuels new bouts of star formation. Our galaxy's ability to keep forming stars today is partly thanks to the fuel it is stealing from these two neighbors. We are parasites masquerading as hosts. But the Magellanics, clouds are not going down without a fight. In fact, the stress of this gravitational torture has triggered one of the most violent fireworks displays in the local universe. Inside the large Magellanic Cloud lies a region called the Tarantula Nebula, 30 Doradus. This is not just a nebula, it is a monster. It is the largest and most active star-forming region in the entire local group. To understand its scale, consider the Orion Nebula, the famous stellar nursery in our own galaxy that we can see with binoculars. If you were to teleport the Tarantula Nebula to the location of Orion, about 1,300 light-years away, it wouldn't just be a bright dot. It would cover an area of the sky as large as 60 full moons. It would be so bright that it would cast shadows on the ground at night. It would be visible during the day. Inside the tarantula, thousands of massive stars are being born simultaneously. At its heart lies the star cluster R136, which contains some of the most massive stars ever discovered, behemoths weighing over 250 times the mass of the Sun. These stars are burning so hot and so blue that they will live for only a few million years before detonating as supernovae. This frantic burst of creation is a direct result of the chaotic dance with the Milky Way. The compression of gas caused by the tidal forces has ignited a starburst. It is the final, glorious scream of a galaxy that knows it is dying. The Tarantula Nebula is the crown jewel of the southern sky, a beautiful reminder of the destructive power of gravity. So, what is the fate of these two companions? For a long time, astronomers debated whether the Magellanic Clouds were just passing by on a hyperbolic orbit, or if they were trapped. Recent precision measurements by the Hubble Space Telescope and Gaia have settled the argument. They are doomed. They are bound to the Milky Way. They are currently near their closest approach, Perry Center, moving at blistering speeds. But they cannot escape the dark matter halo we discussed in the previous act. The dynamical friction of our dark matter wake is dragging them down. It is sapping their orbital energy. The timeline of destruction is set. In approximately 2.5 billion years, the Large Magellanic Cloud will lose the fight completely. It will spiral inward and crash into the Milky Way. This will not be a polite merger. It will be a substantial impact. The LMC weighs perhaps 10-20% of the Milky Way's mass. When it hits, it will shake our galaxy to its core. It will disrupt the orderly rotation of our spiral arms. It might even wake up the sleeping dragon, Sagittarius A, is feeding it enough gas to turn it into a quasar once again. The night sky of Earth, if Earth survives, will be ablaze with the light of a new active galactic nucleus. The peaceful river will become a whirlpool of radiation. The small Magellanic Cloud will likely follow shortly after, or perhaps be torn apart and consumed by the large cloud before they both hit us. Either way, their identity as separate galaxies will be erased. They will simply become more stars in the Milky Way's halo, more fuel for our disk. Any civilizations living on planets in the Magellanic Clouds right now are living on a sinking ship. They are passengers on a titanic vessel that is slowly being pulled into a whirlpool. This relationship between the Milky Way and its satellites highlights a brutal truth about cosmic evolution. Big galaxies get bigger by eating small galaxies. It is a Darwinian universe. The spiral beauty of the Milky Way is maintained by a diet of dwarfs. We look at the clouds with wonder, but physically, we are digesting them. They are not our partners, they are our food. However, there is a cosmic irony waiting in the wings. We are the bully of the local group. We are the giant that eats the dwarfs. But there is always a bigger fish. While we are busy stripping the gas from the Magellanic Clouds, while we are focused on our local conquests, something massive is looming on the horizon. We are so focused on the prey below us that we haven't noticed the predator above us. Across the great gulf of intergalactic space, 2.5 million light-years away, lies the only object in the local group that is bigger, heavier, and more dangerous than we are. It is the Andromeda Galaxy, M31. And unlike the Magellanic Clouds, which are circling us, Andromeda is not circling. It is coming straight for us. It has seen the Milky Way across the dark, and it has decided to close the distance. We have been the eater for 13 billion years. In the next act, we will learn what it feels like to be the eaten. We are about to dance the fatal waltz. We have spent the night looking inward at the machinery of our home. We have seen the black hole engine, the dark matter skeleton, and the stream of stolen gas from our satellites. But now, we must turn our telescope outward. We must look past the prow of our own ship and stare into the deep ocean. If you find the constellation of Andromeda in the northern sky, and look closely at a specific fuzzy patch of light, perhaps with binoculars or even with the naked eye on a perfect night, you are looking at the most terrifying object in our future. You are looking at M31, the Andromeda Galaxy. For centuries, we thought it was just a nebula, a cloud of gas inside the Milky Way. But in the 1920s, Edwin Hubble realized it was an island universe, a city of stars just like ours, but far, far away. Today we know the numbers. Andromeda is approximately 2.5 million light-years away. It is the big sister of the local group. While the Milky Way holds 400 billion stars, Andromeda holds perhaps 1 trillion. It is larger, heavier, and brighter. And unlike almost every other galaxy in the universe, which is racing away from us due to the expansion of space, Andromeda is bucking the trend. It is disobeying the flow. In 1912, astronomer Vesto Slipher pointed his spectrograph at Andromeda and noticed something chilling. The light from its stars was compressed toward the blue end of the spectrum. In physics, this blue shift means only one thing: the object is moving toward you. Andromeda is falling toward us. The mutual gravity between our two massive halos has overcome the expansion of the universe. We are locked in a gravitational embrace. We are rushing toward each other at a speed of 110 kilometers per second, about 400,000 km/h. Every hour that passes, the gap between our two civilizations shrinks by another 400,000 kilometers. The collision is not a possibility. It is a mathematical certainty. Let us fast forward the clock. Let us simulate the view from Earth, assuming our planet survives the swelling of the aging sun, over the next few eons. For the next 2 billion years, not much changes. Andromeda grows slowly brighter, evolving from a smudge to a distinct spindle of light. But by 3.75 billion years from now, the view becomes hallucinogenic. Andromeda will stretch across the entire night sky. Its spiral arms will loom over us, grander and brighter than our own Milky Way. You will be able to see its glowing core, its dust lanes, and its star clusters with the naked eye. It will look like a second moon, but made of a billion suns. The night will no longer be dark. It will be bathed in the ghostly glow of the invader. Then, around 4 billion years from now, the first passage occurs. This is the moment of contact, but collision is the wrong word. Galaxies are mostly empty space. The distance between stars is so vast that when two galaxies crash, the stars almost never physically hit each other. It is like two swarms of bees flying through each other. The bees don't collide, but the swarms get mixed. However, the gravity collides. As Andromeda passes through the Milky Way, the sky will be torn apart. The beautiful, orderly spiral of the Milky Way will be distorted. Our own band of stars will be pulled into a long, twisted tail. Andromeda will be stretched into a hook. The two galaxies will swing past each other, missing the core, but grabbing each other's arms. For the next billion years, they will perform a cosmic dance. They will swing out, slow down, and fall back in. They will pass through each other again and again, like two ghosts wrestling in the dark. With each pass, the friction of their gas clouds will act like a brake. The gas will be compressed, igniting a furious firestorm of new star formation. The night sky will blaze with the birth of millions of blue stars and the explosion of supernovae. It will be the brightest era in the history of our local universe. Finally, about 6 to 7 billion years from now, the struggle will end. The two cores, the supermassive black hole of the Milky Way and the supermassive black hole of Andromeda, will spiral inward and merge. The two spirals will lose their shape completely. The arms will dissolve. The chaos will settle. The result will be a single, gigantic, football-shaped galaxy. Astronomers have already named this future child. They call it Milkdromeda, or Milkomeda. This new galaxy will be an elliptical galaxy. It will not have the beautiful spiral arms of its parents. It will be a reddish-yellow blob of old stars, a retirement home for the survivors of the crash. Most of the gas will have been used up in the starburst or blown away. New star formation will cease. Milkdromeda will be a quiet, dead giant, slowly rotating in the void. And what of the sun? What of Earth? During this chaos, the chances of our solar system being destroyed by a collision are vanishingly small. However, our address will change. Simulations suggest that there is a 50% chance the sun will be swept out of its current orbit and flung into the far suburbs, 3 times further from the galactic center than we are now. There is even a small chance we could be ejected entirely, becoming a rogue star system drifting in the intergalactic deep. But if we stay, any future intelligence looking up from Earth 5 billion years from now will not see the Milky Way. They will see a haze of stars in all directions. They will live inside the core of the new giant. There is a profound melancholy in this future. The formation of Milkdromeda marks the end of an era. It is the peak of our local history, but it also marks the beginning of infinite isolation. As we look even further into the future, the rest of the universe is accelerating away from us due to dark energy. The distant galaxies will move faster than the speed of light, disappearing from our view forever. Eventually, billions of years after the merger, Milkdromeda will be the only thing visible in the sky. The rest of the cosmos will fade into black. Future astronomers born in Milkdromeda will think the entire universe consists of just one galaxy, their own. They will have no way of knowing that other galaxies ever existed. They will never know about the Big Bang. They will be alone in a stagnant island of light. But that is a tragedy for the far future. For us, living in the vibrant youth of the Milky Way, the approaching Andromeda is not a death sentence. It is a promise of transformation. It reminds us that nature is dynamic. Nothing is static. The stillness of the stars is an illusion. We are falling. We are dancing. We are becoming something else. And as we contemplate this massive future merger, we must pull back even further. We have seen the local group, but where does the local group live? We are not just floating randomly. We are part of a river of galaxies. We are flowing toward a destination. In the next act, we will take the ultimate step back. We will see the superclusters. We will see the great attractor. We will see the neural network of the universe itself. We have witnessed the violent history of the Milky Way, the hidden skeleton of dark matter, and the future collision with Andromeda. It feels as though we have covered everything. But in the grandest scheme of the cosmos, we have barely left our front porch. To understand the true context of our existence, we must perform one final, dizzying leap of scale. We must zoom out until the Milky Way and Andromeda, those two titans colliding, shrink down to mere dots of light, indistinguishable from thousands of other dots. We are leaving the local group. We are entering the realm of the superclusters. For decades, astronomers believed we belonged to the Virgo supercluster, a loose collection of galaxy groups. But in 2014, a team led by astronomer R. Brent Tully at the University of Hawaii redrew the map of the universe. They analyzed the motion of thousands of galaxies, subtracting the expansion of the universe to find their true gravitational flow. They discovered that the Virgo supercluster was just a small appendage, a minor suburb of something far, far larger. They found that we are living inside a titanic structure of flowing gravity that spans 520 million light-years across. They named it Laniakea. In the Hawaiian language, it means immeasurable heaven. To understand Laniakea, you must stop thinking of space as a static void with objects sitting in it. You must think of it as a landscape of hills and valleys. In geography, a watershed is a region where all the rainwater flows down into the same river. Laniakea is a gravitational watershed. It is a region containing 100,000 galaxies, 100,000 islands of stars like the Milky Way, that are all sliding down the same gravitational slope. We are not drifting randomly. We are flowing. We are caught in a current. Along with Andromeda, the Virgo cluster, and thousands of others, the Milky Way is moving at a speed of 600 kilometers per second, relative to the cosmic microwave background. We are rushing along the strands of an invisible web, heading toward a specific destination deep in the heart of the supercluster. And what lies at the bottom of the valley? What is the drain? For decades, astronomers were baffled by this motion. They saw that everything in our region of the universe was being pulled toward a specific point in the sky, hidden behind the dust of the Milky Way's own disk, a region called the Zone of Avoidance. They called this mysterious anomaly the Great Attractor. It sounded like science fiction, a monster in the dark pulling us in. But as our X-ray and radio telescopes pierced the dust, the truth was revealed. The Great Attractor is not a single object. It is a place of unimaginable density. It is the gravitational center of the Laniakea supercluster, roughly located near the Norma cluster and the Shapley supercluster beyond it. It is a region where thousands of galaxies are crammed together, creating a gravity well so deep that it influences the motion of objects hundreds of millions of light years away. We are falling toward it. We will never reach it. Dark energy will likely tear the supercluster apart before we arrive. But we are feeling its tug every single day. But the story gets even stranger. In 2017, scientists realized that the Great Attractor pulling us from the front wasn't enough to explain our speed. There had to be a push from behind. They discovered a vast region of almost absolute emptiness located in the opposite direction of the sky. They named it the Dipole Repeller. This is a cosmic void, a region with very few galaxies and very little dark matter. Because it is so empty, its gravity is weak. The regions around it, like ours, have stronger gravity, so they effectively pull matter away from the void. It creates the illusion that the void is repelling us. So, the Milky Way is caught in a cosmic riptide. We are being pushed by the emptiness behind us and pulled by the density in front of us. We are surfing a wave of gravity that spans 500 million light years. When you visualize Laniakea, do not picture a round ball. Picture a neural network. Picture the axons and dendrites of a brain. The universe at this scale is organized into the cosmic web. Galaxies are not scattered like sand. They are strung together on long, thin filaments of dark matter, like pearls on a string. These filaments stretch for millions of light years across the dark, weaving a glowing tapestry. Where the filaments cross, massive clusters of galaxies form, the nodes of the network. Between the filaments lie the cosmic voids, vast bubbles of nothingness where life essentially does not exist. The Milky Way sits on one of these delicate filaments, a tiny spark of light sliding along a nerve fiber of the universe. The resemblance between the cosmic web and the neurons of a biological brain is one of the most haunting coincidences in science. Both structures are networks optimized for connection. Both consist of nodes and filaments. Both are mostly empty space or water. While it is likely just a result of the laws of physics acting on matter, it forces us to ask, are we just a microscopic part of a much larger system? If the Milky Way is a cell and Laniakea is a tissue, what is the whole body? As we drift here, contemplating the immeasurable heaven, the ego of humanity dissolves completely. We fought wars over patches of dirt on Earth. We drew borders. We argued about our place in the center of things. But from the perspective of Laniakea, the Earth is not even visible. The sun is not visible. The Milky Way itself is just a speck of dust, one of 100,000 specks flowing down a drain. We are the moss growing on a rock that is tumbling down a mountain. But there is beauty in this insignificance. We are not isolated, we are connected. The gravity that pulls on you right now is the same gravity that binds the Virgo cluster, that shapes the Great Attractor, that weaves the cosmic web. We are part of the flow. We are citizens of a city that is 500 million light years wide, and now we must make the final journey. We have gone from the Earth to the galaxy, from the galaxy to the supercluster. There is nowhere left to go in space. The only place left to travel is inside. We must return to the consciousness that is observing all of this. We must answer the silent question. What does it mean to know this? We have accepted the collision with Andromeda. We have accepted that our galaxy, the cannibal, will one day be eaten. But as we pull back to the furthest zoom level possible, we realize that even this collision, a crash of titans involving trillions of stars, is just a minor turbulence in a much larger current. We are not just falling toward Andromeda. Both the Milky Way and Andromeda, along with the entire local group, are being dragged sideways. We are caught in a river of gravity so vast that it defies comprehension. For decades, astronomers were haunted by a simple observation. The universe should be expanding evenly. Everything should be moving away from everything else. But when we measured the cosmic microwave background, the oldest light in the universe, we found a scar. We found that one side of the sky is slightly hotter than the other. This is a Doppler shift. It means we are moving through the universe at a staggering speed of 600 kilometers per second, over 2 million kilometers per hour, toward a specific point in the constellations of Hydra and Centaurus. Something is out there, something massive enough to pull millions of galaxies across the void like leaves caught in a storm drain. We named this mystery the Great Attractor. For years, it was a ghost story. We knew it was there because we could feel its gravity, but we couldn't see it. In a cruel twist of cosmic fate, the Great Attractor lies directly behind the zone of avoidance, the dusty, impenetrable plain of our own Milky Way. We were trying to look at the monster through the dirty windshield of our own home. But with the advent of X-ray astronomy, we finally pierced the veil, and what we found was underwhelming. We found the Norma cluster, a massive city of galaxies, yes, but not massive enough. The math didn't work. The Norma cluster was heavy, but it wasn't heavy enough to account for the sheer violence of our speed. It was as if we saw a small hill causing a landslide meant for a mountain. We had to look deeper. We had to look behind the ghost. And there, looming in the darkness, 650 million light years away, we found the true puppet master. We found the Shapley supercluster. If the Milky Way is a house and the local group is a village, then Shapley is a continent. It is the single largest concentration of matter in our local universe. It is a knot of more than 8,000 galaxies packed together, a gravity well so deep that it bends the fabric of space-time into a funnel. This is the Titan. This is the reason we are moving. The Milky Way, Andromeda, the Great Attractor itself, we are all falling toward Shapley. We are all cascading down the slope of existence, sliding inevitably toward this megalopolis of ancient stars. It is a journey that will take billions of years, a journey we will never finish because the expansion of the universe will eventually tear the road apart before we arrive. But for now, we slide. But the story of our motion has one final, terrifying twist. A discovery made only in 2017 revealed that gravity is not the only player in this game. We thought we were only being pulled by Shapley. We were wrong. Imagine you were in a car accelerating down a highway. You assume it's because the engine is pulling you forward. But what if you looked in the rearview mirror and saw that something was pushing you from behind? By mapping the flows of thousands of galaxies, scientists discovered a region of space directly opposite the Shapley supercluster that is fundamentally different. It is empty. It is a void. But in the twisted physics of the cosmos, emptiness is a force. Because this region has almost no matter, it has almost no gravity. It is a vacuum within a vacuum. While the dense regions like Shapley pull, this empty region effectively pushes. It acts as a repeller. We call it the dipole repeller. This is the true horror of our position. We are not just falling, we are being exiled. We are caught between a monster and a ghost. The Shapley supercluster is dragging us toward its fiery heart, while the dipole repeller, this cold, expanding nothingness, is shoving us away, clearing the space behind us. We are fleeing the void to embrace the fire. The Milky Way is merely a piece of driftwood caught in this cosmic riptide, governed by forces so colossal that our entire galactic history is nothing more than a momentary flicker in their interaction. And when we connect all these dots, the repeller, the attractor, Shapley, and the flow of millions of galaxies, we finally see the true shape of our home. We are not lost, we are part of a structure. We live inside Laniakea. In the Hawaiian language, Laniakea means immeasurable heaven. It is a supercluster of 100,000 galaxies, spanning 520 million light years. But it is not a solid object. It is a watershed. Just as water on a continent flows into different oceans, gravity in the universe flows into different basins. Laniakea is our basin. Every galaxy inside this line, including us, is flowing inward, tracing delicate filaments of light that look like the neurons of a giant brain. We are a pulse of electricity traveling down a synapse of the universe. So, what is the ending of this story? If we are flowing, where does the river end? The tragedy of cosmology is that the river has no mouth. It dries up before it reaches the sea. While gravity tries to pull Laniakea together, while Shapley tries to swallow us, a darker force is winning. Dark energy. The vacuum itself is expanding, pushing galaxies apart faster than gravity can hold them together. There will come a time, billions of years from now, when the expansion becomes too strong. Laniakea will be torn apart. The flow will stop. The great attractor will be pushed away from us faster than the speed of light. Shapley will fade into the black. The future of the Milky Way, or Milkdromeda, is one of profound isolation. We will merge with our neighbors, settle down into a quiet elliptical hum, and then the lights will go out. One by one, the distant galaxies will disappear over the cosmic horizon, carried away by the expanding space. We will be left alone in a void that stretches to infinity. Future civilizations born around dying red dwarfs in that era will look up and see nothing but their own galaxy. They will have no concept of an expanding universe, no concept of the Big Bang, no concept of the glorious web of Laniakea. They will think the universe is static, small and lonely. But we are the lucky ones. We are living in the golden age of astronomy. We are the only generation that will ever exist who can see the truth. We can see the river. We can see the monsters. We can see the skeleton of dark matter and the fire of the quasars. We are the universe waking up to look at itself before the eternal night sets in. We are surfing on a hurricane of stars, rushing nowhere, trapped between the push of the void and the pull of the Titan. And it is magnificent. Welcome to the reality of the Milky Way. Welcome home. We have looked inward at the dark heart. We have looked outward at the bleeding satellites. We have traced the skeleton of dark matter that holds us in its grip. But now we must lift our eyes to the horizon. We must look across the great desert of intergalactic space, across 2.5 million light years of near-perfect vacuum, to see the only object in our cosmic neighborhood that makes the Milky Way look small. On a clear autumn night in the northern hemisphere, far from city lights, you can see it with your naked eyes. It appears as a faint, elongated smudge just off the constellation Andromeda. Ancient Persian astronomers called it the Little Cloud. It looks unremarkable, a ghostly wisp no bigger than the moon. But that wisp is a lie told by distance. What you are seeing is not a cloud. It is a galaxy. It is Messier 31, the Andromeda Galaxy. And if you could see its true extent, if your eyes could capture all the faint light from its outer halo, Andromeda would appear 6 times larger than the full moon. It would dominate the sky. It is a titan hiding in plain sight. Andromeda is our twin, our mirror, our equal. Like the Milky Way, it is a grand-barred spiral, a disk of 1 trillion stars rotating around a central supermassive black hole. Its spiral arms glow with the blue fire of young, massive stars. Its halo is littered with the corpses of the dwarf galaxies it has devoured. In almost every way, Andromeda and the Milky Way are siblings, 2 apex predators born in the same cosmic nursery. each ruling their own territories within the local group. For billions of years, they have coexisted, separated by the vast gulf, circling each other like two lions on opposite sides of a river, wary but distant. But the river is drying up. In the 1910s, astronomer Vesto Slipher pointed his spectrograph at Andromeda and measured something that shocked the scientific community. When an object is moving away from us, its light is stretched toward the red end of the spectrum, redshift. When it is moving toward us, the light is compressed toward the blue shift. Slipher expected Andromeda, like almost every other galaxy, to show redshift, the signature of the expanding universe pulling everything apart. But Andromeda's light was blue, deeply, unmistakably blue. It was moving toward us at 110 kilometers per second. At the time, this was puzzling. Why was Andromeda defying the cosmic expansion? The answer is gravity. Andromeda and the Milky Way are so massive and so close that their mutual gravitational attraction overpowers the expansion of space itself. We are bound together, falling toward each other like two stones dropped into the same well. This is not a slow drift. This is a 4.5 billion year death sentence, and the countdown is already ticking. Using the Hubble Space Telescope's exquisite precision, astronomers have tracked the sideways motion, proper motion, of Andromeda across the sky. By combining this with the blue shift data, they have mapped the future. The collision is inevitable. In approximately 4.5 billion years, the two galaxies will meet. The sky will change forever. Let us imagine the view from Earth, or rather, from whatever survives of Earth's orbit. The sun will still be burning, though hotter, nearing the end of its main sequence life. Humanity, if it still exists, will have long since evolved into something unrecognizable or left the planet entirely. But the beings who remain, standing on the scorched surface of Earth, will witness a spectacle never before seen by human eyes. They will look up and see that the Milky Way is no longer a faint band. Andromeda, which once appeared as a tiny smudge, will now fill half the sky. It will be a glowing hurricane, a spiral colossus hanging overhead, its arms stretching from horizon to horizon. The two galaxies will no longer be separated by void. They will be touching. The first pass will not be gentle. Imagine two massive weather systems, two hurricanes, spinning toward each other over an ocean. When they collide, they do not simply merge into one calm storm. They tear into each other. They churn. The same will happen to the galaxies. The spiral arms, which have rotated in peaceful order for billions of years, will be shredded by tidal forces. Stars will be ripped out of their orbits and flung into long, chaotic streams. The neat disk structure of both galaxies will dissolve into a writhing, tangled mess. Andromeda will pass through the Milky Way, punching a hole in the disk, and then, because gravity is a chain, it will swing back. It will return for a second collision, and a third. Each pass will be more violent than the last. The galaxies will become locked in a gravitational embrace, a slow-motion dance of destruction. This is what astronomers call a galactic merger, but that clinical term fails to capture the poetry of what is happening. It is not a merger, it is a waltz. It is two giants locked together, spinning faster and faster, collapsing inward, unable to let go. And at the center of this chaos, two supermassive black holes are also dancing. Sagittarius A, 4 million solar masses, and M31 central black hole, estimated at 200 million solar masses, will begin to spiral toward each other. They will orbit each other, closer and closer, radiating gravitational waves, ripples in space-time itself, until they finally collide and merge into a single, even more monstrous black hole. But here is the strange, almost miraculous truth. Throughout this entire catastrophe, the stars themselves will not collide. This sounds impossible. How can two galaxies smash together and the stars not hit each other? The answer lies in the emptiness of space. Stars are unimaginably far apart relative to their size. If you were to shrink the sun to the size of a grain of sand, the nearest star, Proxima Centauri, would be another grain of sand 10 kilometers away. Space is so empty that even when two galaxies interpenetrate, the chance of any two stars physically colliding is almost zero. The stars will pass by each other like ghosts passing through a wall, but their orbits will be scrambled, A star that once moved in a nice, circular orbit around the galactic center will suddenly find itself on a wild, elongated path. Some will be flung into the outer halo. Some will dive toward the center. The orderly traffic of the spiral arms will become a chaotic swarm. For any planets orbiting those stars, the collision will be terrifying, but not immediately deadly. The Earth, for example, will likely survive physically. The sun's gravity holds us tightly enough that we won't be ripped away, but our address will change. We will no longer be in the quiet Orion Spur. We might be flung into the outer reaches of the merged galaxy, far from the new center, where the sky is dark and lonely. Or we might be thrown inward into the dense, radiation-soaked core. Our fate is a lottery, decided by the chaotic reshuffling of 1.4 trillion stars. But the most dramatic change will be in the sky itself. During the height of the collision, the night sky will not be dark. The violence of the merger will trigger the most intense burst of star formation the local group has ever seen. When the gas clouds of the two galaxies collide, they will compress. Compressed gas collapses under its own gravity, and when gas collapses, stars are born. Millions upon millions of new stars will ignite simultaneously across the wreckage of both galaxies. The sky will be ablaze with blue supergiants, glowing nebulae, and brilliant star clusters. If you lived on Earth during this era, you would not need a flashlight at night. The combined light of these newborn stars would be bright enough to read by. The night sky would look like a perpetual twilight, glowing with the eerie blue-white light of a cosmic construction zone. This starburst phase will be brief, perhaps only a few 100 million years, a blink in cosmic time. But it will be glorious. It will be the last great fireworks show before the fuel runs out. Because once the gas is consumed, once every molecule of hydrogen has been funneled into the furnaces of new stars, the party will end. The galaxy will go quiet. After approximately 6 billion years of chaos, collisions, passes, star formation, and gravitational scattering, the two galaxies will finally settle into their new form. The spiral arms will be gone, the flat disk will be gone. In their place will be a single, bloated, elliptical galaxy, a featureless blob of old red stars slowly orbiting a common center. Astronomers have already given this future ghost a name. They call it Milkomeda, or sometimes Milkdromeda. It will be the graveyard of two once great empires, a monument to the inevitability of gravity. And here, at the peak of this catastrophe, we must pause and feel the weight of what we are discussing. We are talking about the death of the Milky Way, not its extinction. Its stars will remain, but the death of its identity, the spiral structure that we see arcing across our night sky, the structure that has inspired myth and poetry for 100,000 years of human history will be erased. The Silver River will vanish. Future beings, if they exist, will not see a band of light overhead. They will see a faint uniform glow, a shell of stars with no direction, no flow, no story. But for us sitting here in the present, 4.5 billion years before the collision, this future feels distant. It feels abstract. We are safe. We are living in the golden age of the Milky Way. The spiral arms are still intact. The stars are still flowing in their ancient orbits. The night sky is still dark enough to see the river of light. We are alive at exactly the right time to witness the galaxy in its prime. We are the lucky ones. And yet, even as we breathe this sigh of relief, we must turn our gaze further, because the Andromeda collision is not the end. It is merely the beginning of the end. After Milkomeda forms, after the starburst fades, after the gas runs out, the galaxy will face an even longer, slower, and more inevitable demise. We must look past the collision, past the merger, into the deep time of trillions of years. We must watch the galaxy grow old and die. We are entering the long goodbye. Act 8. The Fatal Waltz. When galaxies collide, we have looked inward at the dark heart. We have looked outward at the bleeding satellites. We have traced the skeleton of dark matter that holds us in its grip. But now, we must lift our eyes to the horizon. We must look across the great desert of intergalactic space, across 2.5 million light years of near-perfect vacuum, to see the only object in our cosmic neighborhood that makes the Milky Way look small. On a clear autumn night in the northern hemisphere, far from city lights, you can see it with your naked eyes. It appears as a faint, elongated smudge just off the constellation Andromeda. Ancient Persian astronomers called it the Little Cloud. It looks unremarkable, a ghostly wisp no bigger than the moon. But that wisp is a lie told by distance. What you are seeing is not a cloud, it is a galaxy. It is Messier 31, the Andromeda Galaxy, and if you could see its true extent, if your eyes could capture all the faint light from its outer halo, Andromeda would appear 6 times larger than the full moon. It would dominate the sky. It is a titan hiding in plain sight. Andromeda is our twin, our mirror, our equal. Like the Milky Way, it is a grand-barred spiral, a disk of 1 trillion stars rotating around a central supermassive black hole. Its spiral arms glow with the blue fire of young, massive stars. Its halo is littered with the corpses of the dwarf galaxies it has devoured. In almost every way, Andromeda and the Milky Way are siblings, 2 apex predators born in the same cosmic nursery, each ruling their own territories within the local group. For billions of years, they have coexisted, separated by the vast gulf, circling each other like 2 lions on opposite sides of a river, wary but distant. But the river is drying up. In the 1910s, astronomer Vesto Slipher pointed his spectrograph at Andromeda and measured something that shocked the scientific community. When an object is moving away from us, its light is stretched toward the red end of the spectrum, redshift. When it is moving toward us, the light is compressed toward the blue shift. Slipher expected Andromeda, like almost every other galaxy, to show redshift, the signature of the expanding universe pulling everything apart. But Andromeda's light was blue, deeply, unmistakably blue. It was moving toward us at 110 kilometers per second. At the time, this was puzzling. Why was Andromeda defying the cosmic expansion? The answer is gravity. Andromeda and the Milky Way are so massive and so close that their mutual gravitational attraction overpowers the expansion of space itself. We are bound together, falling toward each other like 2 stones dropped into the same well. This is not a slow drift. This is a 4.5 billion year death sentence, and the countdown is already ticking. Using the Hubble Space Telescope's exquisite precision, astronomers have tracked the sideways motion, proper motion, of Andromeda across the sky. By combining this with the blue shift data, they have mapped the future. The collision is inevitable. In approximately 4.5 billion years, the 2 galaxies will meet. The sky will change forever. Let us imagine the view from Earth, or rather, from whatever survives of Earth's orbit. The sun will still be burning, though hotter, nearing the end of its main sequence life. Humanity, if it still exists, will have long since evolved into something unrecognizable or left the planet entirely. But the beings who remain, standing on the scorched surface of Earth, will witness a spectacle never before seen by human eyes. They will look up and see that the Milky Way is no longer a faint band. Andromeda, which once appeared as a tiny smudge, will now fill half the sky. It will be a glowing hurricane, a spiral colossus hanging overhead, its arms stretching from horizon to horizon. The 2 galaxies will no longer be separated by void. They will be touching. The first pass will not be gentle. Imagine 2 massive weather systems, 2 hurricanes, spinning toward each other over an ocean. When they collide, they do not simply merge into one calm storm. They tear into each other, they churn. The same will happen to the galaxies. The spiral arms, which have rotated in peaceful order for billions of years, will be shredded by tidal forces. Stars will be ripped out of their orbits and flung into long, chaotic streams. The neat disk structure of both galaxies will dissolve into a writhing, tangled mess. Andromeda will pass through the Milky Way, punching a hole in the disk, and then, because gravity is a chain, it will swing back. It will return for a second collision, and a third. Each pass will be more violent than the last. The galaxies will become locked in a gravitational embrace, a slow-motion dance of destruction. This is what astronomers call a galactic merger, but that clinical term fails to capture the poetry of what is happening. It is not a merger, it is a waltz. It is 2 giants locked together, spinning faster and faster, collapsing inward, unable to let go. And at the center of this chaos, 2 supermassive black holes are also dancing. Sagittarius A, 04 million solar masses, and M31's central black hole, estimated at 100 to 200 million solar masses, will begin to spiral toward each other. They will orbit each other, closer and closer, radiating gravitational waves, ripples in space-time itself, until they finally collide and merge into a single, even more monstrous black hole. But here is the strange, almost miraculous truth. Throughout this entire catastrophe, the stars themselves will not collide. This sounds impossible. How can two galaxies smash together and the stars not hit each other? The answer lies in the emptiness of space. Stars are unimaginably far apart relative to their size. If you were to shrink the sun to the size of a grain of sand, the nearest star, Proxima Centauri, would be another grain of sand 10 kilometers away. Space is so empty that even when two galaxies interpenetrate, the chance of any two stars physically colliding is almost zero. The stars will pass by each other like ghosts passing through a wall, but their orbits will be scrambled. A star that once moved in a nice, circular orbit around the galactic center will suddenly find itself on a wild, elongated path. Some will be flung into the outer halo. Some will dive toward the center. The orderly traffic of the spiral arms will become a chaotic swarm. For any planets orbiting those stars, the collision will be terrifying, but not immediately deadly. The Earth, for example, will likely survive physically. The sun's gravity holds us tightly enough that we won't be ripped away. But our address will change. We will no longer be in the quiet Orion Spur. We might be flung into the outer reaches of the merged galaxy, far from the new center, where the sky is dark and lonely. Or we might be thrown inward into the dense, radiation-soaked core. Our fate is a lottery decided by the chaotic reshuffling of 1.4 trillion stars. But the most dramatic change will be in the sky itself. During the height of the collision, the night sky will not be dark. The violence of the merger will trigger the most intense burst of star formation the local group has ever seen. When the gas clouds of the two galaxies collide, they will compress. Compressed gas collapses under its own gravity, and when gas collapses, stars are born. Millions upon millions of new stars will ignite simultaneously across the wreckage of both galaxies. The sky will be ablaze with blue supergiants, glowing nebulae, and brilliant star clusters. If you lived on Earth during this era, you would not need a flashlight at night. The combined light of these newborn stars would be bright enough to read by. The night sky would look like a perpetual twilight, glowing with the eerie blue-white light of a cosmic construction zone. This starburst phase will be brief, perhaps only a few 100 million years, a blink in cosmic time. But it will be glorious. It will be the last great fireworks show before the fuel runs out. Because once the gas is consumed, once every molecule of hydrogen has been funneled into the furnaces of new stars, the party will end. The galaxy will go quiet. After approximately 6 billion years of chaos, collisions, passes, star formation, and gravitational scattering, the two galaxies will finally settle into their new form. The spiral arms will be gone. The flat disk will be gone. In their place will be a single, bloated, elliptical galaxy, a featureless blob of old red stars slowly orbiting a common center. Astronomers have already given this future ghost a name. They call it Milkomeda, or sometimes Milkdromeda. It will be the graveyard of two once great empires, a monument to the inevitability of gravity. And here, at the peak of this catastrophe, we must pause and feel the weight of what we are discussing. We are talking about the death of the Milky Way, not its extinction, its stars will remain, but the death of its identity. The spiral structure that we see arcing across our night sky, the structure that has inspired myth and poetry for 100,000 years of human history, will be erased. The Silver River will vanish. Future beings, if they exist, will not see a band of light overhead. They will see a faint, uniform glow, a shell of stars with no direction, no flow, no story. But for us, sitting here in the present, 4.5 billion years before the collision, this future feels distant. It feels abstract. We are safe. We are living in the golden age of the Milky Way. The spiral arms are still intact. The stars are still flowing in their ancient orbits. The night sky is still dark enough to see the river of light. We are alive at exactly the right time to witness the galaxy in its prime. We are the lucky ones. And yet, Even as we breathe this sigh of relief, we must turn our gaze further, because the Andromeda collision is not the end. It is merely the beginning of the end. After Milky forms, after the starburst fades, after the gas runs out, the galaxy will face an even longer, slower, and more inevitable demise. We must look past the collision, past the merger, into the deep time of trillions of years. We must watch the galaxy grow old and die. We are entering the long goodbye. ASIC 9, the long goodbye, the death of stars and the silence of eternity. The collision with Andromeda has ended. The sky has stopped churning. The blue fire of newborn stars has faded. Milky hangs in the void, a vast elliptical swarm of 1.4 trillion suns, rotating slowly around a central supermassive black hole weighing perhaps 150 million solar masses. It is no longer growing. It is no longer eating neighbors. It is alone. The local group's other members, the dwarf galaxies, the gas clouds, the satellite clusters, have all been consumed or ejected. Milky is the sole survivor, the last light in an expanding darkness. But survival is not the same as thriving. A galaxy is not a static object. It is a process. It is a factory that converts gas into stars and stars into heavy elements, recycling matter in an endless loop of birth and death. But Milky's factory is shutting down. During the violent merger with Andromeda, most of the galaxy's gas reserves were used up in the Great Starburst. The remaining gas was either blown out by supernovae winds or swallowed by the central black hole. There is no fresh fuel, and in the universe beyond Milky, there is no help coming. The expansion of space, driven by dark energy, has accelerated. The cosmic horizon is shrinking. Distant galaxies that we once saw are now receding faster than the speed of light. Their light will never reach us again. They have fallen over the edge of the observable universe, erased from view. Milky is sealed in a bubble of space-time, cut off from the rest of creation. It is a castaway on a cosmic island, and the island is running out of resources. Without new gas, no new stars can form. The stellar nurseries, the glowing nebulae where baby stars once ignited by the thousands, go dark. The spiral arms, which were once lit by the blue blaze of short-lived O-type and B-type stars, are now empty. Those massive stars burned their fuel in just a few million years and exploded as supernovae billions of years ago. Their remnants, neutron stars and black holes, are now invisible, silent phantoms drifting through the galaxy. What remains are the long-lived stars, the red dwarfs, the orange K-type stars, and the sun-like G-type stars. These are the survivors, the tortoises in a universe that once favored the hares. The sun, our sun, will have died long before this era. In about 5 billion years, around the time of the Andromeda collision, the sun will exhaust the hydrogen in its core and begin fusing helium. It will swell into a red giant, its outer layers expanding past the orbit of Venus, possibly past Earth. The oceans will boil, the atmosphere will be stripped away. The Earth will either be engulfed and vaporized or left as a charred, lifeless cinder orbiting a white dwarf. But the sun's death will not be dramatic. It is too small to explode. It will simply puff off its outer layers in a gentle breeze, a planetary nebula, leaving behind a hot, dense core of carbon and oxygen. A white dwarf. This stellar ember will glow for trillions of years, slowly cooling, fading from white to yellow to red to brown, eventually becoming a black dwarf, a dark cinder of crystallized carbon floating in the void. And the sun is not unique. Every star like it will follow the same path. By the time we reach 100 trillion years into the future, 100,000 billion years, every star in Milky that was capable of fusion will have burned out. The red dwarfs, the smallest and most miserly of stars, will be the last to go. These faint embers burn so slowly that they can live for 10 trillion years or more. Long after the sun is a frozen relic, the red dwarfs will still be glowing faintly, the last candles in a cathedral that is slowly going dark. But even they cannot burn forever. One by one, the red dwarfs exhaust their fuel. They shrink into white dwarfs. The galaxy, once a blazing city of light, becomes a graveyard of cooling embers. If you could visit Milky in this era, the sky would be nearly black. You would see no spiral arms, no glowing nebulae, no blue giants. You would see only the faint red and brown glow of dying dwarfs. spaced millions of light years apart, like streetlights on an abandoned highway. The Milky Way's descendants would be living in a dark galaxy, a ghost of its former self. But even in this dying state, there is still motion. The stars, though dead, still orbit. The white dwarfs, neutron stars, and black holes still circle the central supermassive black hole, held by gravity's patient grip, and gravity, though slow, is relentless. Over unimaginable spans of time, trillions upon trillions of years, something called dynamical relaxation begins to dominate. This is the process by which stars exchange energy through close encounters. When two stars pass near each other, their gravitational interaction can cause one to speed up and the other to slow down. Over billions of encounters, this creates a kind of evaporation. The stars with the highest speeds gain enough energy to escape the galaxy entirely, flung out into the intergalactic void. The stars with the lowest speeds sink inward, falling toward the center. This is a process of cosmic entropy. Milky Way is slowly dissolving. The outer halo bleeds stars into the darkness. The core becomes denser and hotter as more and more stellar remnants crowd together. Eventually, after 1019 to 1020 years, 10 billion trillion years, the galaxy will have lost most of its mass. Only a tight cluster of black holes and neutron stars will remain, orbiting the central supermassive black hole in a compact, dark swarm. This is the galactic core remnant, the skeletal heart of what was once the Milky Way. And even this will not last. Black holes, we now know, are not eternal. In 1974, Stephen Hawking demonstrated that black holes emit radiation, Hawking radiation, due to quantum effects near the event horizon. This radiation is incredibly faint, especially for massive black holes. But over immense timescales, even supermassive black holes will evaporate. The central black hole of Milky Way, weighing 150 million solar masses, will take approximately 10 more 100 years to evaporate completely. That's 1 followed by 100 zeros, a Google of years. This is a number so large that it makes the current age of the universe, 13.8 billion years, look like a single heartbeat. But we are not here to flinch from large numbers. We are here to trace the story to its absolute end. So, let us wait. Let the clock run. 10 100 years pass. The black holes evaporate. One by one, they hiss away into radiation and quantum foam until there is nothing left. The stellar remnants that were orbiting the black hole are now free, but there is nowhere to go. They drift in the dark, separated by ever-expanding gulfs of space. The white dwarfs, having cooled for trillions of years, are now black dwarfs, cold, inert spheres of carbon. They no longer glow. They no longer emit light. They are invisible. The universe has entered what cosmologists call the black hole era, and eventually, the dark era. In this final epoch, there are no stars, no galaxies, no light. There is only the faint whisper of Hawking radiation from the last evaporating black holes and the cold drift of subatomic particles through an ever-expanding void. The temperature of space approaches absolute zero. The universe is dark, cold, and silent. The Milky Way, the silver river that shone so brightly for 13 billion years, is gone. Not just changed, not just transformed, gone. Its atoms are scattered across a volume of space so large that they will never interact again. Its story is over. And yet, even in this bleak vision, there is a strange comfort. Because we are not there. We are here. We are alive in the brief, brilliant flash of cosmic time when galaxies glow, when stars burn, when planets can host life. We are living in the universe's adolescence when everything is still happening, when the night sky is still full of light. The astrophysicist Brian Cox once said, "We are a way for the cosmos to know itself." For a brief moment, in the middle of the universe's lifespan, matter organized itself into complexity, into stars, into planets, into DNA, into brains, into consciousness. And now, here we are, standing on a small rock orbiting a medium-sized star in the quiet suburbs of a galaxy, looking up at the light of 400 billion suns, understanding what we see. We are the universe waking up and staring at itself in the mirror, and the face we see is beautiful. The Milky Way will die, Andromeda will die, Milky Way will dissolve into the dark. But right now, tonight, if you step outside and look up, you can still see the river of stars flowing overhead. You can still see the evidence of 13 billion years of cosmic history written in light. You are made of atoms forged in the cores of stars that died before the sun was born. You are standing on a planet that has survived 4.5 billion years of cosmic chaos. You are breathing air, thinking thoughts, feeling wonder. This is the gift of living in the present. The Milky Way is not dead. It is alive. It is spinning. It is hunting. It is breathing fire through the Fermi bubbles. It is holding us in the safe embrace of the Orion Spur. And for as long as we are here, for as long as consciousness persists in this corner of space, the galaxy is not just a collection of stars. It is home. The long goodbye is inevitable, but the goodbye has not come yet. Let us return to the here and now. Let us drift back down from the cold abyss of deep time, back through the trillions of years, back through the dying stars and dissolving galaxies, back through the collision with Andromeda, back through the dark matter halo, past the Fermi bubbles, past the black hole, past the spiral arms, until we find ourselves once again floating in the present moment in the Orion Spur, 26,000 light years from the center, orbiting a yellow star that is neither too hot nor too cold, too young nor too old. We are home, and tonight the sky is clear. Let us rest here, in the knowledge that we are part of something vast, ancient, and still unfolding. Let us close our eyes and feel the motion, the Earth turning, the sun moving, the galaxy spinning, and know that we are exactly where we are supposed to be. Right now, if you step outside, the Milky Way is still a river of light. The stars are still singing. The galaxy is still young. You are alive in its golden age. So, tonight when you close your eyes, let the motion carry you. Let the Earth spin beneath you. Let the sun drift through the Orion Spur. Let the galaxy turn on its invisible axis. You are not standing still. You are riding a hurricane made of stars, moving at 828,000 kilometers per hour through the infinite dark. And somehow, impossibly, you are safe. Sleep well, traveler. The silver river flows on,